absolute value of complex numbers. I'm going to divide this phrase to two terms. First is absolute value, and the second one is the complex numbers. So first, when I go to the absolute values, we have by definition, absolute values is the distance from 0 to a number on the number line. So, for example, absolute value of 2 is going to be equal to the distance from 0 to 2, which is equal to 2. And the absolute value of negative 4 right here is the distance from 0 to negative 4. So that distance is equal to 4. Alright, so the second one is the complex number. By definition, complex number is a sum of a real number and an imaginary number written in form a plus bi. So example, we have 6 plus 3i. So we have the x-axis is a real number and the y-axis is an imaginary number. So 6 plus 3i, 6 on the real number and 3i to the up because it's positive to the y-axis on the imaginary number. So we have 6 plus 3i. Another example you can see is 3 minus 2i. So 3 on the x-axis, the real number, and negative 2i on the imaginary number, on the negative. So this point represents the 3 minus 2i. You compare two terms, you're going to have the absolute value of complex numbers. So you see on the complex numbers 2 points. So what is the absolute value of 6 plus 3i? It is going to be the distance from 0 to that point, 6 plus 3i. And this distance is going to be equal square root of 6 squared plus 3 squared. And they're going to be equal to 3 square root of 5. Similarly, if you do with this point over here, distance from 0 to 3 minus 2i, and have the absolute value of 3 minus 2i is going to be equal to the distance, and that's going to be equal to square root of negative 2 squared plus 3 squared, and they are going to be equal to square root of 13. That is how we're going to calculate the absolute value of complex numbers.